So as we've done a few times before, let's flesh out our server a bit, first with some generic error handling. And to do so, we will create a file called errors.js inside the utils directory. So we'll touch utils errors.js. And inside that utils file, we will add an express error class that extends the generic JavaScript error. We will give it a constructor with a message and a status. We will call super for the parent error class, and then we will say this.message is equal to message, and this.status is equal to status. And then we will create a few 400 errors that we'll use throughout the application. And again, I'm going to start my server here, just so that whenever this file changes, we will see our server restart. We're going to create 4 new errors here. Class bad request error, and it will extend the express error. And this one is simply going to have a message that defaults to bad request and is called with a 400 status code. We're going to have 4 of these, so I'm just going to copy paste to save time. This one is going to be a 401 error. This one is going to be a 403 error, and this one's going to be 404 error. Now, the 400 error is the bad request error. The 404 error we've seen before, that is the not found error. And so it'll just have a default message of not found. These two we have not seen before, 401 and 403. By the way, we skipped 402. That's one you don't see very often that has to do with payments. It's not worth going into at the moment. 405 you might see more often, method not allowed, but again, that's probably not relevant for the time being. 403 is a forbidden error, and we actually might not even use this one, but it's good to introduce it early on. The forbidden error, and this one is the unauthorized error, which we will definitely be using since we will be dealing with authentication for this application. And with these 5 classes sufficiently created, let's go ahead and export them. Module.exports is equal to express error, bad request error, unauthorized error, forbidden error, and not found error. So we've created a number of classes that will handle all of the errors in our application, and now we just need to incorporate those, well, at least some generic error handling into our main server file. So let's head into the server.js and let's require at least the not found error. Let's say const bad request error equals require, and we will say ./utils/errors. And right above the port, let's add another piece of middleware. We'll say app.use, and it will be a middleware function recResNext, and that function will return the next with a new not found error. And all that's doing, again, is if the request does not... Oh, did I put bad request there? It's nice that it handled that import for me. I messed that up. It should have been the not found error. All this does is if the endpoint that the user sends a HTTP request to does not match any of the endpoints in our application, it will then call this middleware, which will call the next function with a new not found error. Now, we will have one more middleware in there, a generic error handler. And so if anything has reached this point and hasn't been handled by our application, it will know that there is an error involved. So instead of saying recResNext, it'll be error recResNext. And we will extract the status equals error.status, or 500 if we didn't handle it correctly, and const message equals error.message. And then we will simply return res.status with the status of the error that has been passed here, .json, and it will have an error with the message and the status. Again, this is error handling that we've done before, but it's always nice to go over it a couple times as a refresher in case we forgot any of it. So now we have generic error handling, and it's time to create some skeleton routes and models. So I'm actually just going to create a new terminal here really quickly so I can add some files while we keep the server running. And I'm going to touch models, Oh, am I in the wrong one? Let's see. Yes, cd into wedding registration, touch models / and let's say user.js here, and then also routes auth.js. And note that we've named the model differently from the route, and that's okay. We'll probably want, at least in a real application, we'd probably want to create a user's route later on as well. It often makes sense, though, to split authentication-related routing from user-related routing for a clear separation of concerns, and that's what we're doing here. But it really doesn't matter. We could call them whatever we want. These are relatively arbitrary. I like to give them very descriptive names as to what they're referring to, though. So that's what we have here. In the auth.js file in the routes, we'll need to create a new router. And our application is really only going to have 2 routes. So we'll say const express equals require express. We'll say const router equals express. Ooh, I did not do that right. Express.router. And then we will create 2 new routes. We'll say router.post. And we will say router.post. And then we will module.exports equals the router. And the first post route is going to be a login route. And that is going to have an async callback that takes the request object, the response object, and the next function. And then we will run a try catch block here. If anything goes wrong, we will call the next function with the proper error. And we will be taking the user's email and password and attempting to authenticate them here. In this other route, this will be the sign-up route or register route, whatever you want to call it. And it will also take an async function, recResNext, as its callback. And it will pretty much do the same thing, except here we will be taking the user's email, password, RSVP status, and the number of guests that they're hoping to bring, and create a new user in our database. Cool. Now we haven't actually implemented any of the logic to handle logging in or registering users, so this probably seems a little bare, but that's fine as we want to keep our routes pretty thin anyway, and we're going to do the bulk of the authentication logic in the user model. So let's go ahead and do the last part and open up this user model here and add just like a tiny outline at least of the algorithms we're going to implement. We won't actually do any of the implementation details, at least until we have Postgres set up. The first thing I want to do is I want to import the unauthorized error from our errors file. Errors, perfect. And then let's create a class user that has 2 functions. A login function that should take the user's credentials and logs them in, and a registration function that takes the user's, ooh, that is not what I wanted. It's always interesting what VS Code thinks I want to write there. Takes the user's credentials and it should register them. And then we will say module.exports equals user. Now before we wrap this up, let's just outline at least what we plan to do in each of these methods. Here the user should submit their email and password, and if any of these fields are missing, throw an error. Then we're going to look up the user in the DB by email. If a user's found, compare passwords, or compare the submitted password with the password in the DB. And if there is a match, return the user. That's a pretty standard authentication algorithm. And then if any of this goes wrong, throw an unauthorized error. Let's just say throw an error. And then we'll actually throw it right here. Throw new unauthorized error, invalid username, or let's say email. I think we're using email here. Email password combo. And then in the registration function, we will have the user should submit their email, password, RSVP status, and number of guests. And if any of these fields are missing, throw an error. And then make sure no user already exists in the system with that email. If one does, throw an error. Then we'll take the user's password and hash it. We'll go into this a little bit more about what I'm referring to there, but for the time being, let's just write this down. Take the user's email and lowercase it, and then create a new user in the DB with all their info, and return the user. And that is pretty much everything we need for the time being. There's a few things here that might seem unfamiliar, so sit tight as we'll be going over them in a minute. I'm going to save this really quickly, head back, make sure everything is fine, don't see any errors here, good to know. Again, all we've done here is outline the algorithms we're going to use to handle authentication. We haven't written any queries, we haven't imported any important libraries, and in fact, we're not connected to our database yet at all. We haven't set up any tables or anything like that, but it is probably a good time at least to save our work because we have the skeleton of our application finished here. So let's run through the traditional Git workflow. We'll say git status, make sure that the node modules are not any of our change files, good to know. Then we will git add all the files, and then we will git commit, and we will say wedding registration application skeleton setup. There we go. Okay, and with that, I think it's time now to handle our Postgres setup. So we'll get into that in the next video.